Yes, I think have you saw what was the answer for this particular problem? Anyone solved? And may I know the results?
So U1 is 7.8.
U1 is okay, 7.8. Okay, then whether your results are concurrent with these results. For today's class, the first five, you please unmute your mic and you please join with us till the end. First five. You please unmute your mic and you please join with us till the end. Amin, Amolya, Anshu, Arvind Bush, Dakshesh. You please unmute your mic and you please join with us. Siddharth, another any deviation from these presented values? Siddharth?
So I'm getting correctly the same.
Very good, very good. And what is the answer for the second problem? More problem I have given to you under the Poisson equation. Yes, solve the Poisson equation. Delta square u is equal to minus 10 of x square plus y square plus 10 over the square mesh with sides x is equal to 0, y is equal to 0, x is equal to 3, y is equal to 3 with u is equal to 0 on the boundary and mesh length 1 unit. Siddharth, what was the answer for this particular problem?
So I only found the first values, initial values. U1,
you only found the first one.
Initial values.
First iteration alone.
No,
first iteration alone you have concentrated.
Yes, sir.
Okay. Tell me the first iteration. Yes, tell me the first iteration cells.
So
here the
U1
yes. One.
No, so
yes, of course.
U1 is 75. U2 is 82.5. U3 is 67.5 and U4 is 75.
Here we don't have any more iteration. Only one set of reading for this Poisson equations, and here we don't have any iterations. Very good, very good. This is what the result is. Very good. do you have any doubts with these parabolic Laplace and parabolic equation? Under I wish to once again will refresh the past content. See, this is what the three different set of problems which we are going to target in this particular unit. One is elliptic equation, the second one is parabolic, the third one is hyperbolic. Under elliptic, we were seeing Laplace as well Poisson. Getting the solution in Laplace and Poisson is quite different, and we need to do many iterations in Laplace, but we doesn't have any more iterations in the Poisson. And this is what the things which we discussed in the last week. That is elliptic equations. The uxx plus the b square minus 4ac value which is lesser than 0, that is categorized as elliptic, which is equal to 0, that is parabolic, which is greater than 0, that is hyperbolic. And now we will target the parabolic equation. Do you have any doubts with these Laplace and Poisson equations? Any doubts? Any doubts? I think yes. If you don't have any doubts, then we will see the parabolic equations. See, a differential equation. My slides are visible and it is audible.
Yes, sir.
Molya?
Yes, sir.
Yes.
So your voice is breaking.
Is said to be parabolic on the region of R. If the b square minus 4ac is equal to all points of the region, the initial value. Yes, just a minute. Yes, someone I think raised some doubts. Yes, any doubts?
No, sir. Your voice was not here properly at that point.
Yes, sir, it was
Now
breaking.
check it. Now it is good.
Yes, sir. Now it's
Or
okay.
still now it is okay. Okay. Yes. Is the initial value of the function u at time t is equal to 0 and the value of the function u and its normal derivative dou u by dou t. Here we are going to concentrate with x and t. Instead x and y we are going to take up with the boundaries as x and t. That is what given here. See the one dimensional heat flow equation. We have various boundary conditions on the left boundary, leftmost boundary, left vertical line, as well on the right vertical. And the initial conditions, we have some initial conditions. Let it be the heat flow. When we are having some heat source, what happens, and the right and left boundaries are exposed to the atmospheric. What happened, the temperature transfers and the that is heat transfer will occur, right? I think have you already aware about the conduction, convection, and radiation? Someone, you please unmute your mic and tell me about the principle of conduction, convection, and radiation. Here, what happened? Once it is known that the conduction, the principle of conduction, convection is known, then we can easily approach this heat flow equation. Tell me what is conduction, what is convection?
So conduction is heat transfer to collision of atoms, sir.
Collision of atoms. Okay. Any other different views, different perspective? Collision of atom. Collision of that is the right or appropriate vocabulary conduct for conduction. Through physical contact, right? Or the heat transfer within a medium. Whether we can say with whether heat transfer within a medium or heat transfer between two different mediums. Heat transfer without a medium. That is conduction, convection, radiation. Heat transfer within a medium, conduction. Heat transfer without between two different mediums, that is convection. Heat transfer without a medium, that is radiation. And if the heat transfer between two different mediums through direct physical contact. So here heat transfer happening by molecule to molecule, and there might be a change in the temperature. And here the left and right boundaries are exposed to atmosphere. What happened here from this medium to the boundary medium, heat transfers occurs. If it is same, if everything is same, then the heat transfer from this region to the atmosphere, heat transfer will be there. So that is what we are going to deal with these one-dimensional heat flow equations. So for this we are going to deal with two different axes. One is x, the other another one is t. Here the dou u by dou t is equal to alpha square into dou square u by dou x square is an important equation in the parabolic type. This was the initial condition for the one-dimensional heat flow equation. Our axis is, our focus is on x and t axis, the solution of the parabolic equation. This is what the basic equation we are going to consider with the parabolic equation. I'll tell you how these can be obtained. Dou u by dou t is equal to alpha square dou square u by dou x square. Let this dou u by dou t as ut is equal to alpha square, here uxx. 1 by here, instead having the constant with x6, and this can be taken into the LHS, and 1 by alpha square into ut is equal to uxx. Let this 1 by alpha square be a, therefore a into ut is equal to xx. So u xx minus a into ut is equal to 0. This is what the equation for parabolic. And see this alpha square uxx minus ut is equal to 0, which can be applied with b square minus 4ac. And we have the a term, that is alpha square. We doesn't have any dou x dou t term, and we doesn't have any dou t square term also. So the a is equal to alpha square, and b doesn't have any b term, and as well c term. So b square 0, and c is also 0. Therefore this entire b square minus 4 is become 0. So this type of problems is categorized or classified as parabolic equation. And uxx minus a ut is equal to 0. Let this equation be equation number 1. U of, this is what the boundary condition, u of 0 comma t is equal to t naught, that is constant temperature along the time axis, and u of l comma t is equal to tl. This is what the left vertical boundary, this is what the right vertical boundary. Constant temperature along the x is equal to l. U x is of x, this is what the various boundary conditions. Boundary condition 1 and boundary condition 2 and boundary condition 3. Let this might be the equation number 2. At present you take it uxx is equal to ui plus 1 comma j minus 2 into ui comma j plus ui minus 1 comma j divided by h square. This is what we were already introduced, but the derivation I didn't discussed. And let ut is equal to ui j plus 1 comma ui comma j by divided by k. This might be remembered with the aid of the Cartesian coordinate. Let the Cartesian coordinate is x and t, and here t alone we were concentrated. When we are dealing with the x, the interval we need to take up the interval as h, and when we are dealing with t, that has to be taken as k. So this is what the uxx and ut, and where h and k are the length of intervals for the variable x and t. So I am applying this in the the equation number 1. So this is what the applied equation. Now the h square can be brought to the RHS, and h square a divided by k, h square a divided by k. Here ui comma I plus 1 comma j minus 2 uij plus ui minus 1 comma j. In RHS we have ui comma j plus 1 ui comma j. Here what is our focus? That is what our main interest. Let this might be the various focus, and what we need to do. My interest is to find this particular point. I know this boundary. I know this boundary. Here I am unaware about this boundary. Still, my focus is to find this one. So this is I comma j. My interest is to find this particular point. What was this point? Amolya, what is this point? I mean, Anshu, if it is this is belongs to u I comma j, what is this point? And what is this point? That is no change in I
j plus 1 and
comma j. Yes, very good. I play j plus 1 and j minus. That is what my focus. So here what I am trying to do, I am trying to get the data for I comma j plus 1 plus 1. That is what my interest. So I am trying to get the information for this ui comma j plus 1. So I am taking ui comma j plus 1 and minus ui comma j, and I am keeping this constant on the other side. So this becomes k divided by h square a into this particular term. Let this term would be lambda. So ui comma j plus 1 minus ui comma j is equal to lambda into this particular term, and now I am transferring this lambda into three different terms, and here also I have I doesn't have any j plus 1 j plus 1 I comma j plus 1 term, so there won't be any issue, but I have u I comma j. So in order to accumulate these u I comma j, I am trying to abbreviate. So this can be taken into RHS. That is what here I have written u I comma j plus lambda into these three different terms. So what I can write, u I comma j plus 1 is equal to u I comma j plus lambda into u I plus 1 comma j minus 2 lambda u I comma j plus lambda u I minus 1 comma j. What I can understand, I can take it out the u I comma j from this two. What happened? I have the coefficient as 1 minus 2 into lambda. So my u I comma j plus 1 is equal to lambda into u I plus 1 j plus 1 minus 2 lambda u I minus j I comma j plus lambda into u I minus 1 comma j. This is what the required formula in order to solve the problems belongs to parabolic. This relation is termed as schemate relation, and how in the way in which we can recognize this formula schemate as here. See, our focus, this is what our focus, and this is what u I comma j, and this is what u I minus 1 comma j, and on the RHS we have u I plus 1 comma j, and the coefficient which is also associated with both the terms are lambda, here 1 minus 2 lambda. By making this diagram, you can remember this particular schema relation. Whether it is understood.
Yes, sir.
This, this is what u I comma j. This is what u I comma j plus 1. This is what u I minus 1 comma j, and u I plus 1 comma j, and the term coefficient is lambda. Here coefficient is lambda. Here 1 minus 2 lambda. In some other slides, I have given this particular picture. So through the picture, you can recognize this schema relation. Further, we need to know about the Bender schema. Let this equation be equation A. See, we choose k for the given h in such a way that the coefficient of u I comma j is 0. When we have the see here, there are some other possibilities. If 1 minus 2 lambda is equal to 0, let assume 1 minus 2 lambda is equal to 0. What happened? This minus 2 lambda is equal to minus 1. Therefore, lambda becomes 1 by 2, right? When lambda becomes 1 by 2, that we assumed as lambda is equal to k divided by h square a, right? Therefore, k divided by h square a is equal to 1 by 2. Therefore, k becomes h square a divided by 2, right? K is equal to h square a divided by 2. Therefore, we have u I comma j is equal to 0 when the coefficient of this u I comma j is equal to 0. We are assuming at that time we doesn't have any intermittent term, right? Even the lambda value become 1 by 2. So I am applying the value of lambda in that particular equation. So I am getting 1 by 2 of u I plus 1 comma j plus 1 by 2 of u I minus 1 comma j. So this becomes 1 by 2 of u I plus 1 comma j plus u I minus 1 comma j. This is what the equation of Bender-Schmidt recurrence equations. When 1 minus 2 lambda is equal to 0, that is what lambda is, that during that condition lambda becomes 1 by 2. Even when that scenario, when we are observing that scenario, that would be the equation of Bender-Schmidt recurrence equation. So the Bender-Schmidt recurrence equation can diagrammatically represented as, see, this is what the diagrammatical representation. See, here we have u I comma j, I plus 1 comma j. Here LHS I minus 1 comma j. On the top we have I comma j plus 1. On the bottom, here the bottom is not essential. This is what the equation for Schmidt. And the for Bender-Schmidt, here the lambda value becomes 1 by 2. On RHS also becomes 1 by 2. Here we doesn't have any term, any coefficient, we doesn't have any u I comma j. So the value at 1, this is what 1 is equal to the value of u at 2, the value of u at 3 divided by 2. By this way, the value of 1, this is not 1. Here, this is what the 1. The value of u at 1 can be derived, can be calculated with an average of the value of u and the value of 3. So this is what the Bender-Schmidt recurrence equations. If the lambda value less than or equal to 1 by 2, the Bender-Schmidt equation stable. Otherwise, the solution is unstable. That is what the condition for Bender-Schmidt relation. Yes, this is what the example 9. Do you have any doubts with these Bender-Schmidt relation? Any clarifications? Any clarifications in Bender's scheme?
What is that stability point at last?
I'll tell you. Stability in the sense the getting the solution in a rapid way, or the reliability of the solutions would be termed as stability. Convergence rate, it would be convergence rate, or the reliability, or the closeness would be stated as stability. Any other clarifications? Amin, Amolya, Anshu, Arvind Bosch, Dakshesh, Anshu.
Sir, mic is not working.
Anshu's mic is not working, sir.
Anshu's mic is not working. Okay,
Yeah.
Amolya. For me, you please cross check whether Amolya joined or not. Arvind Bosch.
Yes, sir.
With Arvind Bosch. Arvind Bosch.
Yes, sir.
Yes. Tell me the current affair, Arvind Bosch.
Yesterday CSK won the match. Sorry. And then I didn't see the paper today, sir. I have to see after completing the class.
Yes.
Sir?
Yes, Arvind
I didn't
Bosch.
see the paper today, sir.
Okay, you tell me the yesterday's news. Apart from the cricket. Okay, you make a detailed note about this game, the match.
Yes, sir. Yesterday, sir, you're asking about CSK match, right?
Yes.
So yesterday, KKR batted first, and then both the openers departed early, and then Morgan and Tripathi steadied the ship, and finally Dinesh Karthik finished with a good cameo of 26 runs of 11 balls. So they posted a pretty par score at the pitch, and then at the second innings, that it was a good start from both Fab du Plessis and Rudraj Gaikwad. But then at the middle part of the innings, there was the innings progression was slightly sluggish, and then finally Jadeja showed his class once again by scoring 22 runs of the penultimate over, and even finally the last over was also thriller, pretty much same like the Kingsal Punjab match and Kingsal Punjab versus RR match. But somehow Lord Shardul Thakur has showed his power once again and scored 3 runs of the penultimate ball of the match. And then even final ball was scored by Deepak Char and the winning runs. Yes.
Against CSK got in the first rank, right?
Yes, sir.
First place.
Yes, sir.
Now Mumbai in the second rank,
Mumbai is
or
No, sir. Mumbai have lost their match yesterday.
okay. What was the status of Mumbai?
They lost to RCB, sir, yesterday. I don't know the standings actually.
So 7th place, Mumbai.
So who
Yesterday
is
there
the,
was
in the second, third position? Gagan?
So the first is in Chennai is in first place. Delhi Capitals in second.
Delhi.
Third is RCB.
Yes,
Delhi, right? Delhi. Instead Delhi. I am seeking about Mumbai, right? Yes. Any other current affairs apart from these?
Sir,
20.
Mumbai Indians standing as a worrying point for Indian team because in the upcoming World
T20 championship. In the Indian squad, out of 15 players, 6 players are from the Mumbai Indian squad only. So it's again like that's the point of concern for the Indian team. If the squad can be changed and like the newer additions can be done instead of Rahul Chahar, if you can get Yuzvendra Chahal, or and instead of like some other players, if you can get the already existing good Indian players, then in that case, yeah, then it would count. But for now, it's like a slightly worrying statistic for India.
No, the thing is good, but we are not getting properly, Pranav. Yes, I think for me it is so. Siddharth, whether the things which is disseminated by Pranav is good for you to hear?
Yes, sir, I can hear, sir, but it's little less. The voice is little less here. The volume is low.
For me,
Yes, sir.
yes, the things which was disseminated by Pranav is good for you to hear.
Yes, sir. Like it was audible and all.
Yes, I think it is some issue. I think so. Yes, I think Pranav. There are 6 different players. They are currently in Indian team from Mumbai, right? That is
Yes, sir, from
what the
Mumbai
thing which.
Indians. Yeah, yes, sir, from Mumbai
Okay.
Indians IPL team. They are right now for the upcoming World T20 Championship. 6 players are selected out of the Mumbai Indians franchise. And
World T20. You are talking about World T20.
yeah,
Okay. Okay.
yes. So in that
It
squad,
is.
six players are from the
It,
Mumbai Indians franchise, and now all of them are. I mean, like not all of them. Rohit Sharma and Jasprit Bumrah, they are in good form. But apart from them, the rest of the 4 players, they are not performing well in the IPL. So that's again a worrying statistic for the Indian team.
yes. Yes. Absolutely. Yes. Any other thing apart from this T20? Yeah, apart from for me, anyone has the today's newspaper? Okay, let me request for me. For me, what was the current affair and what was the today's headlines for me?
Yes, sir. 1 minute, sir. I'll just tell it.
Yes.
Sir, as it was raining today, we didn't get the newspaper, sir.
Oh, okay. The Maoist influence down from 96 to 41 districts. Home Minister. That is what the headlines of Hindu today, and yes. And on one side, we technocrats push for Indian manufacturing. That is what the other informations which is disseminated in the Hindu on the other head, and and one peculiar topic I wish you to focus on one particular topic is for concerning the automobile industries. What was the current scenario of the automobile industries, and even after this BJP government, there are various factors. There are various factors are taken by the central government in order to reduce the pollution, and they are trying to reduce the manufacturers, or they are encouraging the on other hand they are encouraging the e-vehicles, and in that sense, in that line, you try to read the things about the current scenario of automobile industries, right?
Yes, sir.
One
Like
fine day we will discuss about.
Ford exited, sir, from India.
Yes,
They
one
stopped
on one fine day.
manufacturing.
Is not today, Pranav.
Okay,
One
sir.
fine
Okay,
day
sir.
we will discuss about. You try to collect the data and how it affects the current automobile industries who's they are manufacturing the IC engines, and how it beneficial to the e-vehicle manufacturers. you try to collect those data. When fine day we will discuss the things.
Yeah, okay, sir. Yes, sir.
Yes. And for today's, I think there won't be any issue with these derivation of schema and Bender schema. We will solve at least one problem. Find the solution of the parabolic equation dou square u by dou x square minus dou u by dou t is equal to 0. Given u 0 comma t is equal to 0, u of t comma 4 comma t is equal to 0, u of x comma 0 is equal to x into 4 minus x, and assuming h and k is equal to 1, find the values of u up to t is equal to 0. See, while approaching or while learning these parabolic or elliptic or parabolic or hyperbolic problems, there won't be any issue because you're categorizing, you're classified, the problems are classified under one particular head, and then you're approaching. But once you're trying to solve the problem in the end semester, at that time you will feel the hurdle whether this problem belongs to the elliptic or parabolic or a hyperbolic head. That is what the issue. So we need to recognize first whether this problem belongs to.
So, but it's given as parabolic.
Elliptic or a parabolic or a hyperbolic. Siddharth, my slides are visible?
Yes, sir.
Yes. See, this is what the given equation, that is uxx minus ut is 0. Ux, this is belongs to the parabolic equation, right? Because b square minus 4 is equal to 0. We have b square v doesn't have any b term, v doesn't have any c term, so b square minus 4 is equal to 0. Here the lambda value we need to find about the lambda. The lambda which is assumed here is lambda is equal to k divided by h square a. This you need to remember. Here we doesn't have any lambda value. Lambda which is associated with, I'll tell you what is lambda. Here where we have assumed lambda, the lambda assumed the term lambda k square k divided by h square a. K and h are interval. A is the term which is associated with ut. K a is the term which is associated with the coefficient which is associated with t. That is what a. H and k is given as 1, and a here we doesn't have any term, so a is equal to 1. Don't take it as this minus. This minus is already considered in the equation itself. So a is equal to 1. So therefore our lambda is also 1. We need to draw the various boundaries based on this given conditions. From the given condition, that is condition number 1, u of 0 comma t is equal to 0. At x axis y is equal to 0. Here we doesn't have any y. Here we have the axis as t. So u 0 comma j is equal to 0. The second condition, u of 4 comma t, which is parallel to the x axis, right? X is equal to 4, parallel to the time axis. J is equal to 1, 2, 3. J. So therefore u of 4 comma j is equal to 0, and this was the third condition. U of x comma 0 is equal to x comma x into 4 minus x. Instead x I am applying I into 4 minus I. When my I is equal to 0, u, what is the value of u? U is also 0. When my I is equal to 1, therefore I am applying 1 and 1 here, so I am getting 3. When I is equal to 2, 2 into 2, I am getting 4. When I is equal to 3, here 3 and here 1, that becomes 3. When I is equal to 4, U is equal to 0. Why I am stopped I is equal to 4 till I is equal to 4? Because I need to take up these, I need to continue this solution till my U up to T is equal to 5. Schematic recurrence relation is U of U I comma j plus 1 is equal to lambda into U I plus 1 comma j plus 1 minus 2 lambda into U I comma j plus lambda into U I minus 1 comma j. Since my h and k is equal to 1, we have lambda. The lambda value already we were concentrated the lambda value. Lambda is equal to 1. So my lambda, if my lambda is equal to 1, so I am applying this particular lambda value in the schematic relation, schematic recurrence relation. So I am getting U I plus 1 comma j minus U I comma j plus U I minus 1 comma j. This is what my essential equation not to find the y j U I comma j plus 1. And this is what the equation number 4 is essential to find the unknown. Try to draw the diagram. You try to this is what the leftmost boundary and this is what the x-axis. When x is equal to 0, when x is equal to 0, u is equal to 0. When x is equal to 1, u is equal to 3. When x is equal to, u is equal to 4. This is what we have calculated in the last slide. And when u is equal to 0, when t is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3. For all my t value, the vertical boundary is 0, as well the right vertical boundary is also 0. So you try to calculate these different values. We will begin with this. Anshu, no, I think Arvind. Arvind, take your calculator, Arvind. Siddharth, you take your calculator. My focus is to find this particular point. This particular point can be calculated. I plus 1 j. This is what the first term minus my second term plus by this term. Arvind, 2.
Yes, sir.
Sorry. Arvind, you take your calculator. 4. This is what 4 minus 3. This is what the minus 3 plus 0. What is the value?
1, sir.
Whether it is clear how we derived this 4 minus 3 plus 0?
Yes, sir.
Based on this particular formula,
Yes,
I
sir.
plus 1. This is what I plus 1 comma j minus I minus I comma j. This is what my I comma j. This is I minus 1 comma j. This formula we derived based on the various boundaries and various given conditions. What was this? 4 minus 3, obviously 1. So we are getting 1. Okay, good. Arvind, how this can be found? This point can be calculated. You tell me.
Sir, that 3 minus
3. 3 minus
2.
3 minus 4 plus
You are
3.
asking u equal to 4, sir. So which point you are asking? You are asking that.
This point.
Yes, sir. Yes. 3 minus. Yes, sir. Minus 4.
Okay, then whether it is 6 minus 4, you are getting 2, right? Then Siddharthan, how this point can be calculated? Siddharthan,
So 0 minus 3 plus 4.
plus 4.
4.
Very good. Okay. For me, how this point can be calculated? For me, 2 minus 1 minus 0. Sorry, plus 0. 1. Pranav, how this point can be calculated? Pranav?
Yes, sir, yes.
minus
1 minus 2 plus
1.
plus 1. Very good. 0. Okay, Pranav, this point? Zero plus 1, sorry, minus 1
0 minus 1 plus 2.
plus 2. Very good. Okay, then Sriristi, this point 0, 0, minus 1, minus 0, right?
Plus 0, sir.
Plus 0. Yes, what was the results? Z 0, 0, minus 1 plus 0, minus 1. Okay, how this point? 1, 1, minus 0, plus 1, 2, right? 0, 0, minus 1, plus 0, minus 1. This point 2, minus of minus 1, plus 0, 3. And here, Siddharthan,
Minus 1,
Siddharthan,
minus 2, minus 1.
minus 1, minus 2,
Minus 1.
Yes, okay. Then, next point.
0 plus 1 plus 2.
Very good. 3. Okay. Then yes, only one
Minus 4
step ahead.
minus 4
Yes.
minus 3 plus 0.
Yes, 7 minus 7. Then
3 plus 4 plus 3.
very good. Then
0 minus 3 minus 4.
yes, that is what till t is equal to 5. We continued our iteration, and let this might be the temperature difference. This was the various temperature. Let it be the heat transfer rate or whatever it might be the changes. And this is what the solution under Bender scheme. And I'll any clarifications, any doubts in this particular problem? Any doubts?
No, sir.
I think already the time is 11:28. We'll wind up here. Tomorrow we'll meet during 11:30. Thank you, Anurag.
Thank you, sir.